All right, perfect. So this is number 9 on the review that the lecture organizer created. And so this one says the driver of a vehicle observes an impediment. The total stopping distance involves both the reaction distance and the distance the vehicle travels while the driver moves car. Most of this stuff doesn't matter at all, right? So, but that's fine. The braking distance the vehicle travels once the brakes are applied. For a car traveling at a speed of v miles per hour, the reaction distance r in feet can be estimated using this formula. So we have one formula for the reaction distance. So we can write that out right here. RV equals 2.2 times v. Okay, make this a little bit wider. Suppose that the braking distance b in feet is given by, so this is the braking distance. So braking distance b of v is going to be equal to 0.05 v squared plus 0.5 v minus 13. Okay, so we want to find the stopping distance. So the stopping distance d of v, all you're doing is you're adding these two functions. So RV plus BV. Okay. And when you add them, the only place you might go wrong is not combining like terms correctly. Okay. So when we add these, D of V is going to equal, and you can just do them vertically, right? So I would do B of V first, 0.05 V squared plus 0.5 V minus 13. And then when you add it to RV, you want to make sure to line up the like terms. So put the 2.2 V with the V, right? So when you're adding like terms, you know, it has to be all the V's go together, all the V squareds go together. So this is going to be D of V. Okay. So it's going to be 0.05 V squared plus, then you add these two, it's going to be 2.7 V minus the 13. Okay, minus the 13. Now, B says find the stopping distance if the car is traveling at a speed of 70 miles per hour. So V is our speed. So what they're really asking, so this is the answer to part A. In part B, they just want us to find D of 70, okay? They want to find what is the stopping distance when the velocity is 70, okay? So D of V, this means everywhere we see V in the equation in D, we write 70. So it's going to be 0.05 times 70 squared plus 2.7 times 70 minus 13, okay? So this is now a calculator problem, and I will write out every step. I'll write out every step. Even though you probably are going to do the majority of this in your calculator or all of it all at once, I'll still write it out. So 2.7 times 70. That way you can follow along, make sure that you're getting this just fine. Minus 13. So now 0.05 times 4,900. We get 245 plus 189 minus 13, which is going to be equal to, okay, 421. All right. So this right here, well, that's our answer to part B. That's our answer to part B. All right. And does it actually tell us what the stopping distance is in? It probably does. Suppose the braking distance in feet is given. So this is in feet, the braking distance is in feet, and the reaction time is in feet. So that means our answer for the distance is in feet. This is in feet. Okay. And that helps us with part C. Part C asks, interpret D of 70. And we would say the stopping distance when going 70 miles per hour is 421 feet. It's going to take us 421 feet to stop our car when we're going 70 miles per hour, or maybe not our car, but this specific car or vehicle. All right, I'm going to pause here, see if there's any questions on this particular. All right, so we're going to go through number 12 next. And these questions are all either from your homework or from the reviews that are due this week. So if you're wondering where they come from, and they were handpicked by our lecture organizer. And there's 20 questions total on the review, and there's 20 questions total on the test. So we tried to pick the homework and quiz. Actually, not sure if any were quiz, but definitely homework and the reviews that were similar to some of the things on the exam. All right, this number 12 says, using the given graph of the function, find the following. Oh, right, we probably need the graph on this one. It's all right, we'll grab it. All right, we can just go over, here we go. We got our graph now. All right, perfect. So the intercepts, right? The x-intercept is when you touch the x-axis, or intersect, right? Intersect is the proper word. The x-intercept is when you intersect the x-axis, right? That's why it's called a x-intercept. The y-intercept then happens when you intersect the y-axis. Okay, and you'll notice that every point on the x-axis has a y value of 0, and every point on the y-axis has an x value of 0. Okay, so when we're looking for the x-intercepts, we just follow the x-axis. And so the first time we touch the x-intercept is at 0, 0. So 0, 0 is an x-intercept. And then I drew over it. So let's go back and not draw over it. The second point, the second x-intercept, right? This one right here is 0, 0. And this one right here, it actually looks like 2.5, 0, right? Because each tick is 1. So we go 1, 2, but it's a little further. So that's probably 2.5, which is 5 halves. So we have 0, 0, and we have 5 halves, comma, 0. 5 halves or 2.5. You can put 2.5. It should mark you right with 2.5 also. Both should be correct. All right. And then those are your x-intercepts. The y-intercepts happen when the y-axis, when you're on the y-axis. And there is a point on the y-axis. It's 0, 0. Yeah. So in green, we'll have the 0, 0. And then we'll go back so our graph doesn't look messy. There we go. Still a little messy, but not super messy. All right, perfect. So 0, 0 is also a y-intercept. Okay, but I have a feeling you won't put 3 because 2 are the same, right? It just wants intercepts. It actually doesn't care if they're x or y. All right. So when looking at domain and range, domain, so we're doing part B. This is part A. In part B, domain is all possible. It's all possible x values. Okay, it's all possible x values. When you're looking at a graph, it's how far left does it go to how far right it goes. Okay. If you're looking at a graph, it's how far left, how far right. You don't worry about up or down at all. So when we look at, and we'll stick with red for the domain because we were sticking with red for the x-axis. How far, follow this graph to the left. How far to the left does this graph go? The furthest left it gets is -3. So with the domain, we're going to use a bracket if it's a point that we can get to. -3 is a point that we can get to. And then we follow the graph all the way to the right. So follow it to the right now. What's the furthest right we get? Looks like 3. We use brackets for an actual point that we can get to. We'll use parentheses for things that have asymptotes, right? Or we never get there. We never get there. Like infinity. You never get to infinity because it's an idea not a number. Okay, I'm going to pause here, see if there's questions on. All right, so we moved our graph down here and got a new clean one in there. We're going to do range next. So range are your Y values. Range is all possible Y values. And you're going to be thinking about going down to up, down to up. And so now, instead of looking left and right, we're looking up and down. So how far down does this graph go? What's the lowest Y value? What is the lowest Y value that we get? Well, follow the graph down. We're at the lowest Y value, which is at -1. So we're going to put -1. And because it's an actual point that we're going to go to, the Y value is -1. We go to -1. And then what's the highest point? So over here on the left, the highest point would be 1. But on the right side, I'm sorry, I keep hitting the bottom with the bottom of the tablet. But anyway, on the left side, the highest point is 1. But on the right side, the highest point is 2. So it makes it all the way to 2. Makes it all the way to 2. So the lowest point we get is -1. Yeah, sorry, we had a question here and it's okay, great. And we'll go over that question, Nick. Yeah, we'll go over that question for sure. And then the highest Y value is 2. So our range, and both of them are actual points that we can get to. So it's going to be brackets on each. All right. And then we'll go to part C. Part C says the intervals in which it's increasing, decreasing, or constant. So I'm going to go ahead and, right, this is kind of nice. We can just keep pasting. So we want part C, increasing, decreasing, or neither, right? Where is it increasing? Increasing means as we go to the right, it goes up, okay? Constant means as we go to the right, we don't go up or down. We just go to the right. And then decreasing, as we go to the right, we go down, okay? And the biggest thing about increasing, decreasing, and constant, the biggest thing, you have to always write answers in interval notation with X values. Okay? Think about this. If someone asks you, when do temperatures start dropping? Like throughout the year, when do temperatures start dropping? Your answer is not from 70 degrees to 20 degrees. Your answer would be like from September to February, the temperatures are dropping. We want to answer our questions about increasing, decreasing, and constant with interval notation, and you're only talking about the X values. Okay, so let's go ahead and do increasing in red. We'll do increasing in red. And so the graph starts out as we're going to the right, it stays the same. So that's not increasing. The first part is constant. So we might as well do that. We'll do constant in purple. So from X equals, and in fact, you can just write this out. From X equals -3, because that's when we start the graph. We start the graph at X equals -3 to X equals -1. The graph is constant. The way that we're going to write that is in interval notation, -3 to -1. And what does this mean? It means just this. From X equals -3 to X equals -1, the graph is constant. All right, we'll do decreasing, which comes up next. So then as we go to the right on the graph, the Y value goes down. So as we go to the right, hard to show here because the graph is so small, but as we go to the right, our graph goes down. When? From X equals -1 to x equals 1. All you're worried about are the x values. So it's going to be from -1 to 1. From x equals -1 to 1, the y values are decreasing. Okay? Then we have another area of constant, right? From x equals 1 to x equals 2. And so from x equals 1 to x equals 2. So we'd put a union 1 to 2. Oh, yeah, that's fine. From 1 to 2, it's constant. And then from 2 to 3, it's increasing. Because as we go to the right of 2, the y value is getting bigger. So then we would say from x equals 2 to x equals 3, it's increasing. So for increasing, we would put 2 to 3. From increasing, we would put 2 to 3. All right, let's pause here. The other thing I wanted to always mention, that when you're doing increasing, decreasing, the intervals always get parentheses. And the reason why they always get parentheses is that at a specific point, can you say at the point x equals -1, is it increasing, decreasing, or constant? Well, you don't know, because the point is just a point. It's not going up or down. A point isn't doing anything. You need an interval. So this gives you an open interval. And we don't ever want to talk about a specific point. We always talk about an open interval. So when you're doing increasing, decreasing, they always get parentheses. And I know that's a really confusing part, because this makes all of them look like ordered pairs, but they are not ordered pairs. All of the answers to increasing, decreasing, or constant are x values in interval notation. They're interval notation. The way I'd write it in class is this is x interval notation. So anyway, that's fine. We're going to pause here, see if there's questions. We'll resume the recording. All right, and we're going to get our graph again right here. An even function. So anytime it's an even function, you're going to have symmetry to, if it's an even function. I need to write this out so it's super clear, not only somewhat clear. All right, so an even function. All right, it's symmetric to the y-axis. Okay, that means if you fold it over the y-axis, it lands on top of itself. So for us, if it's an even function, the left side of the graph, when you fold it over, it's going to look like this, right? For it to be an even function, the red would have to be over the graph, which is not true at all. If you want an example of what an even function looks like, parabolas are even functions. If you take the right side of a parabola and fold it over the y-axis, it lands right on top of itself. This one is definitely not an even function. Okay, let's see if we can, we're going to paste this again. We're just going to keep using, yeah, actually, yeah, that's fine. So now an odd function, we'll do an odd, if it's an odd function, it has origin symmetry. Symmetry to the origin. Okay, and what you can find to find origin symmetry is you fold over the x and the y axis. So if we take the left side and we fold it over the x-axis, let's fold it over the x-axis first. This is what it'll look like, okay? And I know I'm not perfect. My pen's not 100% great. But if you take the left side and you fold it over the x-axis, so you're folding it down, it's going to look like that. And in the purple, let's take the green and fold it over. It's going to go down here. So it did line up on itself. But the problem is it doesn't line up itself the whole time, right? You have to fold over the X and Y axis onto itself. So our function is not odd. So what's that mean? Ours has to be neither, right? It's not even and not odd. It's neither. All right, let's pause here on this one. Let's see if there are. All right, so here, this was number 19 on the review here that we've got for the lecturing series. And we're gonna follow the steps. We follow the steps for graphing a rational function. And we've got x squared divided by x squared minus x minus 12, right? So the first thing is we want to factor this thing. This factoring, right? The x squared minus x minus 12. We need two numbers that multiply to negative 12 and add to negative 1, all right? Which is pretty nice. It's pretty nice. The reason why I'm saying it's nice is because x squared is by itself. If x squared is by itself, you can use a shortcut. Once you find the pair, you can just write x plus that number times x minus that number. So it's really nice. I always factor really boring. I always do 1 first, 1 and 12. Well, 1 times 12 is not negative 12. So one of those has to be negative. And because we're adding to a negative, the bigger one has to be negative. So 1 times negative 12 is negative 12, and 1 minus 12 is negative 11. Clearly, that's not the pair because it doesn't add to negative 1. So let's try 2 and negative 6. 2 times negative 6 is negative 12. 2 minus 6 is negative 4. And then we have 3 and negative 4. 3 minus 4 is negative 1. That is our pair of numbers. So when we factor this thing, the factored form is going to be f of x equals x squared divided by x plus 3, x minus 4. Okay. All right, perfect. And I know you don't have to like show all that work or write that out, or don't think you have to show all that work, right? But you can. Okay. So we would say this one is not in factored form, and we would say this is the factored form right here. Okay. Questions on that? If you have questions, please let me know. If not, we're going to try to get through as much as we can here. So then the next part of the question right here, right? And I'm going to show it just like it looks in my math lab, because sometimes that can be an issue. Okay. And well, we'll just move this down. Okay. What is the domain? Okay. So anytime you're finding domain, okay, when you're finding domain on these rational functions, I'm only going to talk about domain in this context. Domain of a rational function, you set the denominator not equal to 0. Okay. Because in a rational function, you always have division. Otherwise, it's not a rational function. So you set your denominator, and I'm going to move this along with us. So we're going to copy this, and then we're going to paste it. We're going to move this with us. Our domain then is you set the denominator not equal to 0. X plus 3, x minus 4 cannot be 0. When it's equal to 0, right? When you find the vertical asymptotes, you set the denominator equal to 0. So they're complements of each other. All right. And I'm sure they're going to ask about vertical asymptotes, which is why we're going to put them there. So here you split them up. Either x plus 3 doesn't equal 0, or x minus 4 doesn't equal 0. Subtract 3. Either x doesn't equal negative 3. X can't be equal to negative 3, because then you divide by 0. Add 4. X cannot be 4. Okay. And then our vertical asymptotes are x equals negative 3 and x equals 4. Those are your vertical asymptotes. All right. So when they ask what is the domain, we are going to have to select B, and we are going to write negative 3, 4 as our answer. That's how we're going to input it on our test in my math lab. Okay. You're also, everyone, you're showing your work and you're sending your work into your instructor also. So be sure to show at least some work on these. All right. Any questions on that one? All right. So we're going to get to the next step. This is the next part. The next part, they ask once again if it's in lowest terms. Okay. So they want you to cancel. If there's anything that can cancel, they can cancel, but there's nothing here that can cancel, right? So this third part is, does anything cancel? Because if anything cancels, you're going to have a hole in your graph. So the domain, you're going to have a hole, but nothing cancels on this one. Nothing cancels. All right, let's get to the next part. The next part says, am I in the right thing? I am in the right thing. Okay. The next part says locate the intercepts. All right, perfect. And we're showing exactly what it looks like here, which is why it's taking so much space, but that's okay. All right, and we're going to grab our function again. We need our function. Let's grab our function and bring it back down. Okay, a lot of different parts, but take your time. Take your time. No reason to rush on these. Locate the intercepts of the graph. So to find the x-intercepts, which we also call the zeros, what you do is f of x. Well, all you have to do on a rational function, since we're just talking about rational functions, all you got to do is set the numerator equal to 0. That's all you have to do. Set the numerator equal to 0. All right. So if we do that, we get 0 equals x squared, which means x is 0. So the x-intercept is 0, 0. So the x-intercept is 0, 0. All right. Which also means the y-intercept is 0, 0. Wait. Yeah. Wait. Time out. Everything I said is fine. So now when we're finding the y-intercept happens when x equals 0. So if you plug 0 into the function, f of 0, everywhere you see x, you write 0, is going to be 0 squared divided by 0 plus 3, 0 minus 4. And of course, 0 divided by something that's not 0. That's going to be 0 divided by 3 times negative 4. That's going to be 0 over negative 12, which is 0. The x and y-intercept is 0, 0. So the one that we're going to select here is the graph has an x-intercept at 0, 0 and has a y-intercept at 0, 0. So this one we're going to select A. All right. Any questions on that? Should we pause the recording, see if there's questions? We've done a lot. All right. We know the x and y-intercepts. The x and y-intercept are both 0, 0. Okay. So determine the behavior of the graph at the x-intercepts. So we know from our polynomial section that at 0, 0, right? So the graph will cross the x-axis. So at 0, 0, it's x squared. X squared has an even. So x squared has an even power, which means that it will touch the graph. It will bounce off the graph. So this one, okay, so it's touch. They use the word touch. The graph will cross. No, it doesn't cross. The only thing it does is it touches at 0, 0. The graph will cross. That's not true. The graph will touch, but not cross at x equals 0. Perfect. Ours is C. If it's an even power, it touches. If it's an odd power, which we don't have here, an odd power, it will cross. It will cross. Odd powers cross. All right, now we're definitely going to have to make some space. All right, so we're going to go all the way back up to the top, and we're just going to make some space here. We're going to keep the factored form and the unfactored form. All right, so we want the factored form and the unfactored form because our next question here the next one is going to be, determine the vertical asymptote. So, okay, hold on. We need to scroll this down just a tiny bit more. Oh, I can, okay. So determine the, here we go. Determine the vertical, and then we're going to determine the behavior. All right. Remember, don't panic during the test. You have time. You have time. All right, here we go. This is the next set of questions here. Determine the vertical asymptotes. So we actually already determined the vertical asymptotes. To find the vertical asymptotes, we'll do it again because it doesn't take much time. To find the vertical asymptotes, you set the denominator equal to 0. So for us, it's going to be x plus 3 times x minus 4 is equal to 0. Then we split it up, either x plus 3 equals 0 or x minus 4 equals 0. Then we subtract 3, either x is negative 3. That is a vertical asymptote. Add 4, x equals 4. That is a vertical asymptote. So there are two vertical asymptotes. And the first one is x equals negative 3. And the second one is x equals 4. Because it says the leftmost one. The leftmost negative 3 is to the left of four. All right. If you have questions, please let me know. I'm trying to cover as much as we can here. And we're almost done with this one, I promise. And as you're going through it, it's going to take you less time. You're not copy pasting. You're not explaining. Here we go. Here's our next set of questions. All right. Determine the behavior of the graph on either side of the vertical asymptote. So just like we were talking about the intercepts, the same thing applies. So at x equals negative 3, the way we got it, the multiplicity of this, if we were to talk about it in terms of a polynomial, the multiplicity of the exponent is 1. So this one is an odd number. It's an odd, so it will cross. And by cross, what we mean is it's going to go from negative to positive or positive to negative. And it actually doesn't matter. All we know is that the sign will switch. So both of these are odd, and both of them, the sign will switch. So it approaches infinity on one side and negative infinity on the other. Yep, that's x equals negative 3. And you got to be careful because they already put x equals. So you just have to put in the negative 3. There we go. And then it approaches negative infinity on both sides. Oh, so A is not what we want to choose. We need to choose the one that has both. It approaches negative infinity on both sides of, no. It approaches negative infinity on one side and on the other. We have two of them though. Determine the behavior of the graph on either side of the vertical asymptote. Well, one is infinity and then the other side is negative infinity. Do we just put them both here and select A?
Yeah, it wants both.
And then it approaches. Wait. But ours switches both times. Ours switches both times. Maybe I copy pasted the wrong problem.
That's what they've all been asking, and they want both in that answer. They won't give you credit.
So we just want to put like negative 3 and then comma 4.
Yep.
Wow, that's terrible. Okay. All right. Thank you so much, though. That was Nick, I think. Thank you.
It was.
All right. Thank you, Nick. Yeah, that's a terrible, terrible way to do it. All right. But that's okay. That's how they want it done. What's important too, I can't stress enough that if you show your work on the exam and you write things like this, even if you're not entering them correctly, and you miss it, just send an email to your instructor being like, I missed this problem, but I have the work right. And can you go please check it? more than likely your instructor will go check it. All right, we're going to clean up a little bit more space here. And actually, those problems are new from the new book edition. All right, we're getting to finally the problem that Nick was asking about right here. Determine the vertical asymptotes. We did that. Determine the behavior. These are the last two questions here. Determine the horizontal asymptote, if there is one. Okay. And the way that I talk about these is we look at the degree of the numerator and the degree of the denominator. So let's move this down. Okay, we're going to move this. Oh, actually, we want to look at the original. Let's look at the original. Okay, so when finding the vertical or oblique asymptote, you want to look at the original function. And the degree on top here, the degree on top is 2. The highest power of x is 2 on the top. And the degree of the numerator is also 2. Anytime the degree of the numerator is the same as the degree of the denominator, I call this case 2, and I shared some of my videos with some of the students last time. I don't know if anyone watched them, but that's fine. Case 2. So what you're going to do is you divide the first, as long as they're in order of, you know, like x, the highest power of x is first, you divide the first term on the inside, or first term on top divided by the first term on bottom. So for us, it's going to be y equals x squared, which is the only term on top, divided by the highest powered term on the bottom, which is x squared. X squared divided by x squared is 1. We have a horizontal asymptote. You will never have 2 horizontal asymptotes, by the way. You'll never have 2. We get y equals 1. All right, that's probably not true somewhere, but at least when we used to do it, there was never 1. So y equals 1 is our horizontal asymptote. If you have a horizontal asymptote, you do not have an oblique asymptote, okay? They always ask about both, but if you have a horizontal asymptote, you do not have an oblique asymptote. So the next question is there an oblique asymptote? And the answer is no, because we had a horizontal. Oblique means that it's y equals and then x is involved in it. So just for completion, I am going to copy paste the question here, right here. All right. Do we have any oblique? No, there are no oblique. If you have a horizontal, you don't have an oblique. The only time you have oblique is if you have case 3, where the degree of the numerator is greater than the degree of the denominator. That's the only time that you'll have an oblique. And for us, ours were the same. Ours were the same. All right, we're getting to the last question, I believe.
I do have a quick question.
Yes, please go right ahead, Nick.
So I thought to define y when your degrees are equal, it's dividing by the leading coefficient. So like there's an imaginary 1 in front of x and 2 and x2, and you divide those to get 1, right?
Yes, because the degrees are the same, the x's will always cancel. So you could always use the coefficients, or you could use the entire term.
Okay.
Does that make sense?
Yeah, it makes sense.
Okay, yeah. So, and that's always just like a difference. So for me, I think for the most of the time, it's easy. Well, it doesn't matter. It's the same either way. But yes, Nick, you're absolutely right. If you just want to use those coefficients, you can. Probably the reason why I do terms is that terms is easier to write. And sometimes students are like, well, what are coefficients or something like that? So they're both perfectly fine. Because the degrees are the same, they'll always cancel. Okay, so now, right, and then they want us to do a sign chart. Here we go. All right. You know, all right, that's fine. We're not going to say anything bad about anything right now. But here's the next part. Determine the points at which the graph intersects the horizontal asymptote. The horizontal asymptote is y equals 1. So that means that we need the function to be equal to 1. So let's take Yeah. So what we're going to do is take this form right here. We're going to take this form. I'm just going to rewrite it real quick. R of x is equal to x squared over x squared minus x minus 12. And then we need R of x to be 1. Is the y value ever equal to 1? And the way we're going to solve this always is we're going to multiply both sides of the equation by the denominator, which is x squared minus x minus 1. X squared minus x minus 12. And then on the right side, they're always going to cancel. And so this is what we have on the left side. I'm going to move it up here so that we have a little bit of space. 1 times x squared minus x minus 12 is just 1. And that's going to be equal to x squared. We're going to subtract x squared on both sides. It looks like a quadratic, so we want to set it equal to 0. Turns out it's not a quadratic. We're going to be left with negative x minus 12 equals 0. This is linear. Let's add 12 on both sides. We get negative x equals 12. Divide both sides by negative 1. X equals negative 12. So yes, it does intersect. The graph intersects the horizontal at the point, and you type an ordered pair. So the ordered pair is going to be negative 12, comma 1. The ordered pair is going to be negative 12 for x, and the y, which was R of x, was 1. The y was 1. All right, let's pause here. There's still one more question, but we're going to pause here. See if there are questions. So here we've got x equals 0 from the zeros. We call these their x-intercepts also. And then the vertical asymptotes, these are the zeros, then are going to be x equals negative 3. We got that before. And then we got x equals 4. So we're going to have intervals here from negative infinity to negative 3 to 0, 4 to infinity. These are all the possible intervals. And then last time I did show on Saturday how to do a sign chart, but it was like well after the actual end of the hour. But what you can do is just put your function and plug in a number in between these. So put your function down here, and you can just do everything as calculator work. I'm not a big proponent of calculator, but that's fine. Pick a number in between negative infinity and negative 3. Pick a number in between negative 3 and 0. Pick a number between 0 and 4, and then 4 to infinity, and then plug it in. When you plug in negative 10 in your calculator, plug it in, square it, you get 100. And then on bottom, you get 100 divided by negative 10. That's going to be negative 7. And then negative 10, that's going to be negative 14. All you worry about is what's positive, what's negative. So you have a positive divided by a negative and a negative. 2 negatives make a positive. That means it's above the x-axis from negative infinity to negative 3. Plug in negative 2. On top, it's always positive. So you're going to get 4 over 1 times negative 6. There's only one negative, so this is going to be negative. Let's plug in negative 2. We get 4 over, well, same thing. It's actually 4 over 1. Oh, no, it's 2 instead. 2 is positive, so it's a 5. 2 minus 4 is negative 2. So there's still one negative. It's still negative. And for the last one, plug in 10. If you plug in 10, you get, all of them are positive, right? If you plug in 10, they're all positive. 10 squared is 100. 10 plus 3 is 13. And then 10 minus 4 is 6. They're all positive, so it's positive. So the graph of R is above the x-axis at negative infinity to negative 3. And then you put a comma in between these, and you put 4 comma infinity. Where they're above, positive means above. Negative means below. So it's going to be below from negative 3 to 0, and then comma 0 to 4. All right, so you can do a super quick sign chart like this. I know I showed sign chart like with each individual, which I think is better, but we're running low on time. We're running low on time. Although I'll stay after. If you guys have questions on anything else, I'll go over it. I've got office hours starting at 11 anyway. All right, determine the behavior. No, wait. We did that. There's, oh, the graph. We just got to do the graph now. Here we go. So now we want to know what the graph looks like. Here we go. Let's paste it. Which one of these is the graph? Okay. Well, there's a lot of different ways you can look at it. Ours starts off positive. We might be able to make these bigger, but that's okay. Which starts off positive, and then it goes negative, and then it stays negative. So it bounces. Remember, it bounces off 0. So which one of these bounces off 0? And the only possible one it could be is C. C is the only possibility, right? And it was positive, and then it's negative twice, and then it's positive again, and it bounces off 0. Bounces off 0, or touches, right? If you remember when we went through it, it touches at 0. So this one is probably the most difficult problem on the entire exam. Although I will say it's probably not as difficult to get, you know, I would like, you don't want to just look at this problem and go, this problem is too hard. There are tons of places where you can get partial credit on this problem, right? Without doing too much work. Without doing too much work at all. There's lots of places where you can get partial credit. So don't just look at the problem and go, oh, I remember that, it's impossible. Go through it, you know, get your intercepts, get your zeros, get your horizontal asymptotes, get all those things. Now, if you don't get where the intersection of the graph and the horizontal asymptote, that's fine. Remember, you get credit for doing each part of the problem. All right, let's pause this one here. This will be the official end of the lecture. So I'm going to stop the recording